Good afternoon, gentlemen. Welcome to the engineering class. My name is Mr. McHugh, and I trust at this point that we've already taken attendance and everyone who's here is supposed to be here, and anybody who was here on accident has gone somewhere else. Thank you all for signing up for the course. I'm very excited about it. I really enjoy teaching this course, and I think you're really going to enjoy being in the course. Obviously, I'm not here today, and I apologize for that. I'm currently in grad school at Spalding right now, in the second year of working towards a doctorate in education. I'm in class right now as we speak, and I couldn't get out of it, unfortunately. So I have created this video. I know it's not the best way to start the first day of school, but it's going to cover all the same first day stuff that I would have talked about if I had been here. And a link to this video is also going to be posted on the Plus Portals page. So if there's something that you forget to write down or don't have time to write down, or you just need to go back and refer to it later on, I will post the link to this video on Plus Portals, so you can find it there. Before we get too far along, I did want to take a moment and tell you a little bit about myself. I'm from Northern Illinois originally. A lot of people ask me if I went to St. X, and I did not. I went to Notre Dame for undergrad and earned a Bachelor's of Science in Mechanical Engineering. I never did go into the engineering field, though. I immediately did a service program for teaching, and I liked it so much that I stayed in it. I spent 6 years in Mobile, Alabama as a high school teacher, and then in 2004 moved to Louisville to work at St. X, and I'm now entering my 15th year at St. X. I did coach football and baseball for quite a few years, but I had to give both of those up in order to go back to grad school. And now just a few thoughts on this course. We can't teach you to be engineers in 1 year of high school. It's just not possible. But what we can do is give you some very good exposure and experience with the problem-solving process, the thought process that engineers use. There's a lot of math and science that you've learned over the years. Some of you even taken computer programming classes or CAD classes. You've taken lots of different courses. And what I like about this course is that it really gives you an opportunity to put all that to good use. This is not a typical course. You're not going to take a lot of tests and quizzes, but you are going to have to think a lot. And it is going to be driven by how much work you want to put in. One other thing that I really enjoy about the course is that it forces students to get over some fear of failure that they might have. Throughout your educational journey, some of you may have fallen into this category of you're good at solving problems, but only if you know the exact route you're supposed to take in solving that problem. A lot of guys are good at sitting down, looking at a problem, and as long as they know exactly how to get to that last step, they're comfortable starting the problem. But for some students, they get trained to where if they don't see how to get to that last step, they get kind of paralyzed. They are worried about even taking that first step because they don't know necessarily what the second step is going to be. And this course, I think, does a nice job of forcing you out of that comfort zone, of forcing you to solve problems that don't have a right answer, forcing you to think about that solution path and get comfortable in ambiguity, to be comfortable knowing that you don't have to be perfect, that you just need to come up with a good plan and then execute that plan and see how well it worked. And if it didn't work well, try to figure out why it didn't work well. And then, if time allows, go back and change it. Go back and improve it. A large part of engineering is based on failure and learning from those failures. But you have to develop a certain level of comfort with that fear of failure. And I think this course does a nice job in exposing you to projects that give you that opportunity. So just real briefly, before we get logged in or anything like that, I'd like to move you around and put you in the seat for the seating chart. I have a seating chart on the next slide. The first slide is going to be the seating chart for G period. So if we could pause the video when the G period slide comes up and let everybody get moved around and get in the right seat. And then if it's H period, if we could pause the H period slide and let everybody get moved around. And then we'll go ahead and continue on after that. So here's our G period seating chart. If it's currently G period, could we please pause the video for a moment and allow everybody to get moved around? Here's the H period seating chart. If it's H period, if we could pause it here and allow everybody to get moved around. If it's G period, obviously we can skip this one. All right, now that we're situated at our correct seat, I ask you to please log into your computer. You're going to need to log in to this computer probably 2/3 of the time. If we're in this classroom, you're going to be logging into the computer. If we're not in this classroom, we're going to be out in the Innovation Lab, which you can see through the windows right now. If you can't remember your username or password, I understand some of you maybe haven't logged into a campus desktop computer in maybe several years. Please try this. For your username, try your last name, first initial, and graduation year. So a senior named John Smith would type in Smith J19 as the username. For your password, it may still be the original password from your freshman year, which would be STX, all lowercase, followed by your freshman year student ID number. So 09 and whatever the 3-digit number is for your student ID. If that doesn't work, or you've changed your password and you just can't remember it, please go see Mr. Carino right now. He's in his office right down the hall. It is vital that you are able to log into this computer. Hopefully it's not very many of you. Hopefully you can remember your password. But we need to be able to log into the computers. So hopefully you've had a chance to log in. Because it's the first time logging in, you're probably going to have to go through the setup process. So just be patient. Let it go through the setup. It's probably going to take a couple of minutes. But that's why it's important that you sit down at the same computer each day, because you don't want to have to go through that process every single day. While our computers are setting up, we can use our iPads to kind of keep moving the process forward. If you could please, take your iPads and go to Plus Portals and go to the engineering course page. We're going to use Plus Portals quite a bit. You need to be able to log into the Plus Portals course page. Most of you probably have the username and password saved on your iPad, which is fine. Every so often, you're going to need to log into Plus Portals on our desktop computer. So if for some reason you don't remember the username and password, at some point, you're going to need to figure out what they are. But at a minimum, everybody should be able to go to Plus Portals on their iPad. On the engineering course page, located under Files, is a PDF of the course syllabus. Please download that syllabus now and import it to Notability. Every one of you should have Notability on your iPad. It's a requirement for your math course. It's also one of the easiest ways to edit a PDF. So take a moment, import that PDF of the syllabus into Notability. And this is how you and your parents are going to sign the signature page at the end of the syllabus. That signature page will eventually be submitted as a PDF to Shobi, something which we'll go through here in a minute. But for right now, I just need you to download that syllabus and import it into Notability. Hopefully most of you have the syllabus downloaded at this point and imported to Notability. If you're still working on that, please continue to do so, but I'm going to talk through just a couple of the main points of emphasis on the syllabus. I'm not going to read the whole thing to you at this point of the day. Second to last period, you've gone through this several times already. I know it gets a little old, but there are some important things that I just need to point out. Right there at the top, there's my voicemail extension if you want to leave a voicemail. I doubt anyone's going to do that. Underneath that is my email address. Please make use of that early and often if you have questions. I generally reply to it pretty quickly. So if you have a concern, if you're absent, you want to know what we're doing that day, please just send me an email. The course description, as I already said, is really going to introduce you to the problem-solving practice of engineers. Yes, we're going to talk about some of the different engineering disciplines like mechanical, electrical, civil. Those are some of the broadest ones. Now there's going to be a little bit of some others as well, but those are going to vary depending on the different projects that we do. Some of the projects are going to be individual, where you have a chance to work by yourself. Some of them are going to be in groups, and that is very typical of real-life engineering. Most engineering is done in groups now. So you have to be able to work with other people. Some of you might be very good at that, and some of you might need a little work at it. One thing I really like about the course is it gives people a chance to have to do that. If you're working in a group, everybody's responsible for doing their part. It's also a chance for people maybe in the past who have dominated a group to work on stepping back a little bit and allowing other people to utilize their strengths as a member of a group. And one other thing that's pretty important is this idea of presenting your results. Engineers have to be able to communicate. Yes, they have to be good at math and science, but they have to be able to communicate what they do. This includes in the written word, being able to write down and explain what you did and why you did it in proper English. Also, it requires you to be able to talk about it, to be able to get up in front of your peers and discuss what you did and why you did it on a certain project. So being able to communicate and present your results to others is going to be a major point of emphasis in this course. Regarding the textbook, I sent out an email on Thursday. Hopefully several of you already purchased the textbook code, and by that you went to the business office and got a receipt, which you'll then bring to me, and I'll give you the code. I probably gave some of you the code before school today. If not, don't worry about it, but you should come see me either before school Monday, or at the very latest I can give you the code in class on Monday. But you should have that receipt of purchase absolutely no later than the beginning of class on Monday. I do not want anybody asking me during class Monday to go to the business office to take care of that. It should be taken care of before we get to class on Monday. That textbook code is going to give you access to this website, whiteboxlearning.com, which I'm going to run through some of the high points of it here in a minute. It's a very dynamic website. It's going to provide us with not only the science content behind most of the projects that we'll do in this course, but it also provides us with computer modeling capability, which is kind of a CAD-based modeling system, but it also allows us to run simulations. And before we're done here today, I'm going to describe our first project to you and show you a quick demonstration of what the website can do in terms of modeling that project for us. This website will also track time spent on it, as well as how much content you have viewed, both of which are going to be a component of your course grade. So what do you need to bring every day? You should already have purchased a textbook code by the beginning of class on Monday. Have some sort of way of keeping notes. You want to keep them on the iPad, that's fine. Otherwise, have a 3-ring binder or a notebook to write stuff in. Some way of calculating, which could be your iPad, but could also be your calculator. And you should have the Shobi app, because most, if not all, of our assignments are going to be submitted electronically via Shobi. So how's the course graded? There's going to be a certain amount of the grade based on how much time you spend on the Whitebox website, which we'll talk about more on Monday. A certain amount of time on the design, a certain amount of time spent reading. Another 25% is going to be the quizzes and worksheets that you do. These are embedded in that Whitebox website. They're online, and you can take them basically open book. When you get to the questions, you're allowed to look back through the notes. So that turns into a little bit of an effort grade at that point. 10% is going to be based on certain design thresholds, which we'll talk more about on Monday, and 40% is going to be the project output. That does not mean project success. It means how well do you make a plan, execute a plan, evaluate that plan, and then communicate the results of that plan. That is what project output means. Now, these numbers are valid. They are subject to change, and if they are changed, I will clearly let you know in advance of any of those changes taking place. Absences, same absence policy that's in the handbook, number of days absent plus 1. I do encourage you to not miss this course a lot. It's going to hurt you more than in other courses because you'll just really fall behind. A lot of what we do, we have to be in the classroom to do. And if you're in a group, then you're really going to be hurting the group with that absence. So if you think you're going to be gone for every Friday this first semester, I don't want to say you shouldn't take the course, but you really need to think about it. Not being in the room is going to have a serious effect on your ability to stay current in the course. In terms of my availability, I am here every single day before school by 7:30. Now, this is not my homeroom. My homeroom's in 109. So at about 7:50, I'm going to have to leave. But I will be in the innovation lab every morning from 7:30 at the latest to 7:50. So you can come see me. I'll also be here after school most days until 3:30. If you need to come in and catch up on a project, please do so. You really don't have to ask me ahead of time. Just come in and do it. But you do need to try to stay as current as possible with projects that we're doing. As far as group grading, we'll talk more about it when we get to our first group project, but some of the grade component will be a grade that is common to the entire group. As it says in the syllabus, collaboration, communication, compromise. These are all necessary 21st century skills. They're also necessary elements of working in a group and necessary traits of being a successful engineer. With regards to the lab safety contract, some of you are taking another science course. If you've already signed a lab safety contract in that course, that's fine. I just need to know who has that contract on file. If you have not, there is a lab safety contract posted on PLUS Portals. Please download it, sign it, and submit it to Shobi just like you're going to submit the syllabus. There will be 2 separate folders on Shobi, a folder for the syllabus and a folder for the lab safety contract. If you've already signed a lab safety contract for another course, put a note in that Shobi folder telling me the name of the teacher and the name of the course where your lab safety contract is located. this is going to be your first assignment. Getting your syllabus signature submitted by Tuesday and getting your lab safety contract submitted by Tuesday. Both of those assignments are posted on PLUS portals in the homework section, which means they're also on the calendar. So please make sure you get those downloaded, make sure you get them signed, make sure you get them submitted to Shobi as a PDF. Please read through the course expectations. I don't want to read them all to you. Basically, we're going to follow the rules in the handbook, and I expect you to work hard in the course. It's an elective. You chose to take the class. I generally get very good effort and very good production out of the people that take this course. Hopefully you took it because you have some interest in engineering. Even if you think you might not major in it, you might at least be interested in it. And that's key. If you have no interest in engineering, you may want to question why you took the course. And obviously the last page is the signature page. As it says, signed and submitted to Shobi by Tuesday, by the start of the class period. After that, it's late. You should download the document to Notability, get it signed, and submit it as a PDF. This is the only acceptable form of submission. I'm not going to accept paper printouts. I'm not going to accept a photograph of a paper printout. If you don't know how to submit things to Shobi as a PDF, particularly from Notability, please see me. I will gladly show you how to do that. That is something we will be doing throughout the course, submitting documents to Shobi as a PDF. You will lose a lot of points if you don't submit documents to Shobi as a PDF. Make sure you know how to do it. If you don't know how to do it, make sure you see me. I will gladly show you how it's done. While we're talking about it, let's go ahead and set up our Shobi folder for the course right now. Hopefully most of you have the Shobi app already downloaded and active on your iPad. If not, please download it now or download it over the weekend. But these are the class codes necessary to sign up to the appropriate folder. If you are in G period, use the G period code, NHK7E. If you are in H period, please use the H period code, PTM65. That should give you access to the appropriate folder, and you should immediately see two assignments, two folders for assignment submission. One folder for the syllabus and one folder for the lab safety contract. Neither of these assignments can be submitted right now because they require a parent signature. So please make sure you go home this weekend, you get the documents signed, and you submit them as PDFs to the appropriate folder. I will remind you on Monday, and they are due at the beginning of class on Tuesday. At this point, I wanted to give you just a real brief introduction to the Whitebox Learning website. If you already have your code, please feel free to log in right now. You'll have to do it on the desktop. That's why we're in this classroom. The website really doesn't work very well on the iPad. You can read some of the content, but it doesn't scroll very well. And you definitely cannot use the design tool. So it is very important that we can log in to the desktop. You can also work at home on this, assuming you have a desktop computer at home. It also works on Macs, so if that's all you have at home, it'll work on that. It just doesn't work on iPads very well. So you'll need to log into some form of desktop computer. So let's take a look at the features of this textbook website. Once you're at the Whitebox Learning website, you can log into our current project. Our first project is going to be the balsa wood glider. So I would go to the glider icon and enter the student ID access code that you were given, which is different for everybody. The group ID is the same for everybody, G96Y, but everybody has their own student ID access code. So I would log in, and this test student of John Smith, you can click any one of these and they all take you to the same place. They all take you to the different tabs that you could click on. Your textbook is this research tab, and as you read through it, for each project you will be told what the challenge is, the goal of the project. The goal for the balsa wood glider project is maximum hang time. You're going to design, test, and build a glider out of balsa wood. Our goal is going to be to make use of the laser cutter as much as possible. You could cut these out by hand with an X-Acto knife, but because we have the technology and we have the equipment, last year we made them using the laser. Worked out very well. We got very exact pieces. It just requires us to use Adobe Illustrator a little bit. The program, the Whitebox website, will output a PDF of your design, but we're going to need to modify that PDF a little bit in order to make use of the laser cutter. We'll cover all that when we get there. But this research tab gives you all the content that you need in order to be able to do the project. So you'll read through it just like a textbook. Every so often you're going to come across a quiz. Those are the quizzes and worksheets that count towards 25% of your grade. Again, it's an open book quiz and worksheet basically. So you can always go back if you aren't quite sure of what the question is, and you can read up again in order to be able to answer the question. If you get it wrong, you get one more try. For reduced credit, you won't get full credit on the second try, but at least you get some credit. And then you would move on to the next question. The design tab, the engineering tab, is where you get to create your own balsa wood glider. You get to change all the specs. Size of the wings, shape of the wings, size of the stabilizers, all of that. So I'll go ahead and open a test file. And we'll talk through this more on Monday. But clicking on the eye lets you see that part. If you don't want to see that part, click on the eye and it goes away. If you want to work on a part, you click the wrench and that allows you to modify it. So if I want to modify the wing, I simply need to see the wing, click on the wrench, and now I can change all sorts of different aspects of the wings. Now, I'm not going to get into what all these mean. That's in the reading. Part of the reading is you figuring out what the heck dihedral means, how the different shapes are going to matter, how the location of the wing from the front is going to matter. Color really doesn't matter all that much. But all these different features are going to be very important to the performance of this plane. And you're also able to test it. That's in the competition tab. So if you have a saved model that you want to test, you can go to Save and Enter Competition. And in the competition tab, you'll see your design right here. You just have to choose yourself as contender 1, and if you want to fly against somebody else, you can choose them. You could also just fly against yourself. Make yourself contender 1 and contender 2. And what it will do is it will fly the plane. It will do a computer simulation of how long that balsa wood glider is going to fly. Now, I will go ahead and tell you up front, the minimum time it can give you is 1 second. And at the beginning, most of you are going to get a time of 1 second. Because it's going to take a lot of fine-tuning, a lot of refining your design, a lot of iterations of you testing it on the computer, going back into the research, maybe checking a couple of things, figuring out why your design isn't performing as well as it could, making some adjustments, and then testing it again. So you can test this over and over and over on the computer before we actually sit down to make the physical version of your glider. We're going to try to optimize it. We're going to try to get it as good as it can be on the computer before we try to create it in real life. So those are just a couple of the features of the website. It's very powerful. It's very informative. It's a very good website, and it allows us to do some really neat things. So in the time we have left, I wanted to run through a couple of slides that kind of emphasize, reiterate what engineering is, but also talk about a couple of things that it is not. At its most basic, engineering is all about designing a solution to a problem with certain constraints, with no set of step-by-step instructions. An open-ended problem that you need to define, develop a solution to, stay within certain parameters, with no real idea of how to get there. That is what engineers do. Engineering is not about being the smartest person in the room. It is also not about never being wrong, although there are a lot of funny t-shirts out there, such as this one. There are a lot of misconceptions that engineers are by default super intelligent. Now, you do want to be somewhat good at math and science in order to be an engineer. But personally, I think one of the most important attributes of an engineer is creativity. Another one is tenacity, the ability, that propensity to not give up on a problem. You have to love solving problems. You can't get scared off by a problem. You should get energized by a problem. Solving a problem is what engineers live for. It doesn't matter what kind of problem it is. It doesn't matter if it's a crossword puzzle, if it's a riddle. Engineers love solving problems. Some other qualities of engineers. Here's a whole list. And not all of them have to do with being super smart. Imagination, accuracy of thought, economy, thinking about being efficient. If you ever are driving somewhere and you're thinking about what's the most efficient way to get there, that's thinking like an engineer. Capacity for hard work, got nothing to do with intelligence. But you got to be able to work hard. And the ability to think and speak lucidly, clearly, the ability to communicate. This is true. Engineers get excited about things that nobody else really cares about. I can't really deny that. But this is in large part what people think engineers do. Drink a lot of coffee, and not much else. If you've never read Dilbert, it is a treasure trove of engineering humor. And if it's not funny now, it probably will be by the end of the semester. So, just a quick recap of what you need to be doing this weekend. If you have not already, it is imperative that you go to the business office and pay for your textbook access code. That needs to be done before the beginning of class on Monday. I am not going to let you go in class on Monday. I can't say that enough. You need to do it either after school today, before school Monday, or at lunch on Monday. we are going to be using class time on Monday to work on the research for the glider project. You will have to be able to log in to the Whitebox website. Make sure you have purchased your textbook. Also this weekend, you should have already downloaded your syllabus to Notability. If not, please get that done. Get the syllabus signed and submit it to Shobi. There is currently a folder on Shobi for the syllabus submission. Submit it as a PDF. It's also listed as a homework assignment on Plus Portals. Please get that done. Same with the lab safety contract. Get that downloaded, get it signed, and submit that to the appropriate folder on Shobi as a PDF. Again, if you're already taking another science course this year and you're already filling out a lab safety contract for that course, let me know the name of the teacher and the name of the course. Type that information in as a comment in the Shobi folder for the lab safety contract. Please make sure you know how to log into our school computers and that you know how to log into Plus Portals. If you're having issues with either of those, please see Mr. Carino as soon as possible. And lastly, if you do have your textbook access code, if you have your login information for the Whitebox website, feel free to get started on the glider project. We will be taking class time on Monday to begin the research, and we will talk through a more extensive timeline of the project on Monday, but it never hurts to get started. Thank you for your attention. If you do need to refer back to this video, the link is posted under links on the Course Plus Portals page. And I hope you guys had a great day, have a good weekend, and I will see you in class on Monday.